Hello everybody and welcome to Code for the Titya. Today we're going to be doing two snap circuits projects, number 49 and number 50. Let's get started. So we have project 49, neither this nor that, and project 50, not this and that. So I'm going to explain both of these and go a little more in depth on how these two work. 48 and 47 and 48 from the last video. So let's start with project 49. So I'm going to put this to the side. And the parts we need are the project building board, the three snap piece, 4 2 snap pieces, the S1 and S2 switches, the resistor, and then the D1 module. So let's and also the battery module. So let's get started. So first we're gonna place our battery module, and then we're gonna place our place our switches and our LEDs. So we're gonna place the arrow facing downwards, away from the one peg away from the battery, and then we're gonna place S2 right next to the D1 module, and then the S1 right next to it, and then this R1 module connects the plus to the plus of the LED, and then we have the 2 snap piece connecting both of the switches together like this, and then a 3 snap piece connecting this to this. So we connect this, the light turns on, but we'll talk about that. So and then we connect these two to these two, so like this and like this. So now the circuit's done. So I'm going to talk about what a NOR, a neither this or nor that is. So this is called a NOR circuit. So if we talk about this, if I can get my pen. Okay, so we talked about OR gates in the last video. So here's an OR gate. So OR, right? An OR gate. So I'm gonna zoom in so you can see it better. So an OR gate, here's the input, and then here's the output. So there's 2 inputs, so A and B. So if we put a 0 and a 0 into an OR gate, we'll get a 0 out of an OR gate. If we put a 0 and a 1 in, we'll get a 1. If we put a 1 and a 0 in, then we'll get a 1. If we put a 1 and a 1 in, we'll get a 1. Now a NOR gate is basically just the opposite of that. So NOR will be an input and then an output. So if we try this out, if we put a 0 and a 0, all the outputs are just inverted. So this will be a 1 out now if it's a 0 and 0. And if it's a 0 and a 1, this is a 1, so now this is going to become a 0. This is a 1 and a 0, so this is going to become a 0. And then a 1 and a 1 will also become a 0. So whatever's a 1 here will become a 0 here. Whatever's a 0 here will become a 1 here. That's why it's a NOR gate. So it's a NOT, so inverts it. So now if we look at that on our circuit, let me zoom out. So we try it out. So right now it's a 0 0. None of the switches are pressed or like on. So the light is on, like the NOR gate says. 0 0 is 1. Now if we turn one of them on, it's off, like this. If we turn the other one on, then it's off. And then both of them on, it's also off. So that's a NOR gate. So hopefully that made sense, and we're going to move on to project 50. So we can just disassemble this. I'm going to leave the battery on so we can work on that. So it's the same parts, so just a couple other pieces. So what we need now is the battery one here and then we want the LED at the same place, and then the S1 switch will be 1 at the same place too, and then we want 2 3-snap pieces. So we need to get another 6-snap. So 2 3-snaps. One connecting this to this, and then a 1-snap piece that's on one side of the slide switch, S1, and connect this to this. So now if we go to the R1 module and connect this to this, and this light turns on. And then we also just want another 1-snap on the switch S1 and connect it with S2 like this. So that's the final circuit. So let me explain this a little bit. So we talked about OR and NOR, and last time we also talked about AND gates, right? So if we do the same table again, input, output, like this. So in an AND gate, if there's 0 and a 0, then there's a 0. If it's a 1 and a 0, it's a 0. If it's a 0 and a 1, it's a 0. But if it's a 1 and a 1, then it's a 1. Like in the NOR gate, everything's inverted. So this is called a NAND gate. So NAND, so it's a not AND. So this is a not OR, this is a not AND. So we make the same table. So 0 and a 0 would now be a 1. A 1 and a 0 would now be a 1. A 0 and a 1 will now be a 1, but a 1 and a 1 will now be a 0. Everything's inverted. So now if we test that out, so let's see. So right now it's a 0 and a 0, so the LED's on, like this, 1. So if we do a 1 and a 0, so let's do this, then it's off. 1 and a 0, the LED's off. A 0 and a 1, so this switch, see, check my connections. What were the connections? A 1, 0 and a 1 should be on, right? So if we turn it on, the LED's not turning on. Oh, no, S2's not working either. So I'm gonna try this again. There's probably something wrong with the circuit. So let me just place these wires back again. So 0, 0 is on. Now if we take this back and press the switch, it doesn't turn off. Oh yeah, I'm just thinking about this wrong. So if we look at it, this is the troubleshooting process. I'm just thinking about this wrong. The LED is supposed to be on. So if we press the press switch, it'll still be on. If we turn on the other switch, it'll still be on. But if both switches are on, then it'll turn off. That's the NAND gate. I was thinking of like the OR gate. So, like this. Both switches are on because this one's on, and I'm pressing this, so the LED turns off. But if both of them are off, then the LED's on. One of them is on, another one's on. But both of them are on, then this will be off, like the truth table we had. So that was it, and I hope you learned something, and please like, share, and subscribe.